Okay, this is 3.1. This is investigating quadratic equations in vertex form. Okay, and so that right there is vertex form of a quadratic equation. Y equals a times x minus p in brackets squared plus q. Okay, this is the graph of a parabola. Okay, and we're just going to look at how changing some of the different parts of that equation are going to change what the graph looks like. Okay, so we will start, and this is in your book. It's on page 143, and I'm just doing comparing some graphs where I'm going to have a different value for a. Okay, so I'll start by putting in a few different equations. A simple x squared. All right, I can't put all 6 in because I can only fit 4 here, so I'm just going to take a variety. X squared, 2x squared. Okay, I'll try 1/2 x squared. Okay, and then let's do a negative. Okay, so we're going to graph them all. Our blue one is not showing up. So let's see. Maybe it doesn't like the way I put that in. We'll just change that. We'll put a multiplication sign in there and hopefully that'll work. Okay, there we go. Okay, so take a look. When you have your red one, that's just kind of a normal, everyday vertex form quadratic equation. And so it's just got an a value equal to 1, and you can kind of look at it. Just has sort of a normal width. Okay, you make a greater than 1 a value. You can see that's the green one, and it's going to narrow. Okay, the blue one, it widens. Okay, if we make it even smaller, 1/8 instead of 1/2, it's going to widen even more. Okay, so when that basically the smaller the absolute value of a is, the more it's going to widen. If we make it a negative a value, it's going to be upside down. Okay, we can also see that with the yellow, and the yellow one is identical to the red one, except because it's a -1 instead of 1, it's upside down. Okay, so that should tell you a little bit about the effect of a, okay, in a quadratic function in vertex form. Okay, a affects. Whoa. Okay, hold on. A is going to affect how wide or narrow it is, and it's also going to affect whether it opens up or down. Okay, so a large A means a narrow graph, also known as a parabola. That shape is called a parabola. And a small a is going to be a wide parabola. All right, the other important thing here is a positive a will give you a parabola that opens up, and a negative a will give you a parabola that opens down. All right? Okay, now moving on, we're going to see how, let's see. We're going to look at how changing the value of q is going to affect the shape of the graph. Okay, the shape or the position or whatever. Okay, so what we do, we don't have a p-value here, right? In this case, we just have p equal to 0. Okay, that's why we don't have like x minus p in bracket squared. It just becomes x because p is 0. And so the only thing we're changing here is q. And what you see is you've got 3 parabolas. They're the exact same shape, and there's just an up and down shift. Okay, so the x squared ones just crosses at the origin. Okay, x squared plus 4 is actually shifted up 4 units, and x squared minus 2 is shifted down 2 units. Okay, so that's pretty simple. The effect of q, if q is positive, you're going to have an upward shift, and if q is negative, you're going to have a downward shift. Okay, and the last thing that you need to do here is we're going to look at how P changes things. Okay, so we're not going to have a Q value. We'll just say Q is 0, so we're just adding it on to the end, a 0, so you don't see it. Okay, and this is, we're just going to try out the ones that they have in the book there. X squared, x minus 2 squared. Okay, we're going to get rid of the Q value there. We just still want a Q value of 0. Okay, and an x plus 1 squared. So we're going to have a positive value of Q. Okay, actually, the positive value of Q is when you have x minus 2, P of P. So x minus P, so that means in the green graph, P equals 2. In the blue graph, P equals negative 1. And you see that what you have is just a shift to the right or a shift to the left. Okay, so again, I'll say that the green, it's x minus 2, so P is positive 2, and you can see that it shifts 2 to the right. And then the other one shifted to the left. So to describe how the value of P changes the graph, when P, let's take a look again, when P is a positive number, like 2, you're going to have a shift to the right. And when P is a negative number, like there, x plus 1, so P is negative 1, you have a shift to the left, okay? And you shift to the left, whatever that value is, okay? Now, it gets a little complicated when you're changing all three, okay? But if that's the only thing you change, a positive P value means a shift to the right. And a negative P value means a shift to the left. Okay, so those are the three variables in there. When you actually have an A, P, and Q value, you're still going to have an X and a Y, but it's A, P, and Q that are going to determine what your parabola looks like when you graph it. Okay, so just a little summary of what we need to know about quadratic functions. Okay, y equals a times x minus p squared plus q. A can be 0. Or a can't be 0. P can be 0, q can be 0. A has to be something other than 0. Okay, these are both ways of writing quadratic functions, and in both cases, A can't be 0. Okay, P and Q can be 0. B and C can be 0. A can't be. Okay, so those are two ways of representing a quadratic function. Okay, the graph is a parabola. Yeah, that's what you'll recognize when you see an equation that looks like that. Okay. The vertex is either the highest or the lowest point of the parabola. Okay. That vertex has coordinates P and Q. Okay. P is the x-coordinate of the vertex. Q is the y-coordinate. This is written out pretty nicely in the lesson notes on the course. Okay. The vertex is a maximum value if it happens to open down, and it's a minimum value if it opens up. Okay, the graph has an axis of symmetry. That's not a very good one, but that's a vertical line that's going to cut it into two equal halves that are mirror images of each other. Okay, and that's going to be represented by the equation of a vertical line, which is x equals something, and that something is P, the x-coordinate of the vertex. Okay, so the axis of symmetry is represented by the equation x equals P. And I think that might be all I have to say. Make sure you look at the lesson notes because it's nicely summarized there if I missed something.